Hi, in this video, I'm going to show you how to create a simple Revit family. This is going to be an IKEA dining table. This will probably be one of the simplest model you will ever make. In this video, you will learn the steps that you need to take in order to create a trouble-free Revit family and basic modeling tool. Before you start the lesson, be sure to download the PDF file of the cut sheets in the description below. In creating a good Revit family, there are steps that we need to follow. But before we can discuss that, let's talk about the two types of families. We have statics families and parametric families. First is statics families. Statics families are families that are fixed in size. So when you think of this, I want you to think of Eames lounge chair. If you create a family for this, it comes in one size, so you don't need to create a different type for it. The second type of family is parametric families. Parametric families are families that are flexible in size and sometimes in quantity. So think about windows and doors. If you create a family for it, you want to be able to change its height and width per type. Now with the steps. Step number 1 is to choose template. This will determine what category family will be grouped under. This also determines if family will be a hosted or non-hosted family. Now, it is important to choose your template carefully because if you decided that you want to change your family from hosted to non-hosted later on, that is not possible. Step 2, add reference plane. This gives vertical and horizontal reference to geometry. Step 3, add dimensions. These dimensions will allow for future constraints and parameters. Step 4, add constraints and parameters. This controls how family behave when types are created. Step 5, build geometry. This is what your family will look like. Step 6, flex. Flex is the term Revit used when testing to see if family is behaving as designed. It is important to flex often, especially every time you add constraint or parameter. Final step. Test family in a project. This ensures that finished family behave and appear inside a project as designed. This means that you will load your finished family into a project and test it there. Now that the steps are out of the way, let me demonstrate and elaborate those points for you. So we're going to start with creating new family files here. And so first step is to select a template. Since this is going to be a dining table, so the appropriate template would be furniture. Once you have selected the template, you can open. Usually when you open the template for the first time, it'll give you 4 tabs to start with. So if you have a larger screen, you can just view tile and view all 4 views at the same time. Since I'm on a laptop here, so I'm going to close all inactive views, okay? And just have the reference view open. Reference view in a normal project file would be a floor plan. So in reference view, we have 2 reference planes that was given to us by default. This is center, left and right, and this is center, front and back. And you also notice that they are all pinned. The intersection of these 2 reference planes will determine the insertion point for your family. Another thing I want to point out to you is that reference plane is not the same as reference line. So be sure to use reference plane in family creation, not a reference line. Now that the first step is done, the second step is to create reference plane. So I'm going to create 4 reference planes, and those 4 reference planes, I will use it to control the sizes of the table. And remember, we're on top view. So I'm placing one here, there, okay. And don't forget to name all of your reference plane. So since this is center front back, I am going to call this one back, and I'm going to call this one front. Whatever makes sense to you. And since this default reference plane is called center, left, right, I'm going to call this one left. And this one right. Once you've done that, we are going to equalize the 4 reference plane we've just placed, since we want the insertion point of our table to be at the center of the table. I'm using dimension to equalize those distant. We're going to try to keep our dimension outside of the geometry. So if you imagine an outline that follows the 4 reference planes that we have just placed, that will be an outline of the table as view from the top. Now let's focus our attention on the front view of the table. From the front view, you will see the same reference planes as you saw on the reference level. This is center, left, right, which is the default reference plane. This is left, that we have just placed a minute ago. And this is right reference plane. On elevation view, you also have reference level, which the reference level will correlate with the level in which you place your family later on. For this purpose, if I zoom in closer, you will see that there is a reference level, and there is also another default reference plane that came with the family. They are locked together, but for this purpose, we don't need to reference anything to the reference level, since the reference plane is already locked to the reference level. So I do not want to mistakenly reference the reference level, so I'm going to hide this. So we will highlight the reference level, click once to select, then type HH on your keyboard to temporarily hide. So now we will be left with only reference planes on the front elevation. What I'd like to do is I usually like to have my reference planes a little bit longer than I need, so that later on when I have to place dimension, I can find them easily. So in this case, I'm going to extend this default reference plane a little bit past the left and the right reference plane. And I also noticed that it wasn't named. So I'm going to name this. Since this is going to be the bottom of the table, or where the legs touch the ground. I'm going to call this base. Now that we have the reference plane to determine the bottom of the table, we will need another reference plane to determine the top of the table. So we will create another reference plane in this view. This time I'm going to use a keyboard shortcut. RP is the shortcut that we use for reference plane. For this, I'm going to call it top of the table. For now, we already have enough reference planes to start dimensioning and adding constraint and parameter. Now let's shift our focus back to reference level. Now let's talk about constraint and parameter. These two reference planes are being constrained by pin. We don't want our insertion point to move, so pin makes sense. Now the four reference planes that we have added ourselves, since we want to be able to move them around to get different sizes for the table, we don't want to place any type of constraint to it, such as pinning or locking them. Now let's add parameter to control the width and the depth of the table. So I will use this dimension to control the width, and I will use this dimension to control the depth of the table. We're going to start with width. After you select the dimension that you want to turn into a parameter, then we will go to our ribbon here on this icon, create parameter. This parameter we are going to call it width. And we're going to make it a type parameter. And it'll be grouped under dimensions. In case we come back a few years later, we need a reminder of what this parameter is for. Let's add a tooltip. And that dimension is changed to a parameter. Now let's make this dimension a parameter that controls the depth of the table. We will follow the same process. This time we're going to call it depth. It will also be type parameter, group under dimensions, add tooltip. Now that we have added two parameters to control the width of the table and the depth of the table, let's flex it. To flex it, we have to go to family type icon over here. Click once to open this dialog box. So we can just change this number to flex. That's one way to do it. So I'm going to change the depth to 4 feet and the width to 15 feet just to see if those reference planes will move according to the dimension we entered. Let me move this out of the way and then click apply. So it did. Great. So since we already know the size of the table, we can create types to control those sizes. So I will create type right away by clicking on this icon here. And for the first type, I'm going to call it small. The width of the small table is 5 feet 7 inches. 5 space 7. And the depth of the small table is 2 feet and 10 inches. So 2 space 10. Let's move width up. So I'm going to highlight width and click on this icon to move it up. So width comes before depth. Now that we have created a type for this family, let's flex it. Now we have a type that control the small dining table. Let's make another one to control the large dining table. We will follow the same process. This time we're going to call it large. And the width of the large dining table is 7 feet 11 inches. And the depth is 3 feet. Let's flex that. Let's flex it a few times just to make sure. It looks good. Let's shift our focus back to front elevation. Over here, we won't have any constraint or parameter, since the height of the table always stay fixed at 2 feet 4.5 inches. So all we have to do is place the top of the table 2 feet 4.5 inches away from the base. So I'm going to use permanent dimension to do that. That's all we need to do. We won't place any type of constraint to top of the table reference plane. Now let's move back to reference level. Now we are ready to create geometry. So the first geometry that we're going to make is the tabletop. On the Create tab, we will use extrusion. And after you execute the command, it will take you to Modify Create Extrusion. Under Draw tab, I'm going to use Rectangle. I like to make my rectangle larger or smaller than the top of the table. This is because later on I will have to constrain the edge of the table with the reference plane that control the width and the depth of the table. So I'm clicking Modify to get out of this command, of the Draw command. And on my keyboard, I'm going to type AL for Align. I'm going to align the left edge of the table with our reference plane. Do the same for the right. Do the same for the back. And do the same for the front. Now that we have constrained edges of the table with our reference plane, the next thing to do is to set a work plane. The work plane we set will help determine the starting point and the stopping point of the geometry. To do that, we'll go here on this icon, and then we will select from a list here, which you will see that on this view, the only two reference planes that we can reference to are base, which was the default that we renamed, and top of the table that we have created ourselves. We will not reference anything to reference level. In this case, we are creating the tabletop, so it makes sense to reference to top of the table. Okay, out of it. You will not see any changes. Second, we will determine the height or the thickness of this geometry. So if you look here on the property palette, extrusion start at 0 feet 0 inches. That will be the top of table reference plane. Extrusion end 1 foot 0 inches. This means that the extrusion will be placed 1 foot 0 inches above the reference plane. But in this case, we want the extrusion to go down instead of go up. And we only need it to go down an inch. So I'm going to change this value to -1 inch and apply. Let's see what it looks like. We are going to confirm that we're done with this geometry. I'm going to open a 3D view and view tile for us to see all 3 views at the same time. Zoom all. So that's what we have. Looking at the front view, I can see that the extrusion is above the reference plane, so some of the setting is incorrect. To see what went wrong, I will have to select the geometry and check the property palette. In the property palette, I can see that the negative value is not entered at extrusion end, so I'm going to do so now. Great, the next steps, we're going to add the bevel edges on the bottom of the tabletop. So the best place for me to do that is from the top view, which is the reference level. I'm going to TW this and zoom all. This time I'm going to use void geometry to subtract from the bottom edges of the table to create that bevel that we see on the cut sheet. We will click on void form. After you click that, it's going to give us a drop-down selection. I'm going to use void sweep. Once you execute the command, it's important to understand that when you use sweep, whether it's void sweep or solid geometry sweep, it is a 2-step process. First, you're going to sketch the path, and then later on, you will draw the profile. The profile will follow the path. So first step, sketch path. And I'm going to follow the same steps as I did to draw the edges of the table. So I'm going to draw the rectangular bigger than I need. Get out from this command, and I'm going to align. This time I'm going to use this icon to align, which is the same as the shortcut, the keyboard shortcut. So I align and lock them all. It is important to remember that you do not want to align and lock to another geometry. It is best practice to align and lock to reference planes whenever possible. Now we are ready to confirm that we're done with the sketch of the path. The second thing to do is to draw the profile. So with this profile here, we need to be on the elevation views. So hopefully you can see this profile here. Think of that as a sheet of paper in which you have to draw the profile. With that said, we will not be able to see the surface of the paper if we go to the front or the back view of this table. So we can only see the profile when we're on the right or on the left of the table only. I'm going to go to the right. That's the paper that I was talking about. Now we're ready to draw the profile. So I will need to go back to Modify Sweep and click on Edit Profile. It'll take us to sketch mode again. This dimension is 1 1/4 inch. Escape out. This dimension is 1/2 inch. Cancel the command. Let me zoom in. It seems like I missed one of the lines, so let's do that again. This dimension is 1.25 inch. Okay, so that we see the sketch line. The last thing to do is to connect the two ends together to create a triangle, which will in turn give us the bevel edge. Before I confirm that I finish with this, I'm going to open all 4 views for you at the same time. Okay, since this is a 2-step process, we have to confirm twice. So the first confirm is we're confirming that we're done with sketching the profile. And then go back to Modify Sweep. And the second confirm is confirming that we're done with this entire process. So on this view here, you will see that the void geometry is subtracting from the solid geometry. Over here as well, I'm going to change it to thin line mode so that you can see it easier. Hopefully you can see it better there. I'm going to save my work and then go back to reference view. Now that we are done creating the tabletop, we can now shift our focus toward the legs and the center support of the table. So let's start with the legs. So from the cut sheet, we know that the legs is offset toward the center of the table on both sides, 1 foot and 1 inches. So we're going to start with creating a reference plane. So I'm using shortcut on my keyboard, RP, for this. So I'm placing the left reference plane and the right reference plane. And before I forget, I want to rename this. I'm calling this left of table. And I am calling this right of table. Now we're going to place these 2 references at the right location, which is 1 foot and 1 inches and 1 inch. Same as the opposite side. Select the object that we want to move. Whether this table is large or small, this distance doesn't change. It's always stay at 1 foot and 1 inch. So we have to place a constraint to these two reference plane. We always want these two reference plane to be 1 foot and 1 inch away from this one and that one. So the best way to do that is to lock the dimension. So now whenever these two reference plane move, this one will move with it to maintain that 1 foot and 1 inch. Let's create a geometry for the legs. Refer back to the PDF file to know what the shape looks like. I'm going to use blend geometry this time. When we're using blend, it's also important to understand that this is the two-step process. You will need to create a profile for the bottom and a profile for the top in order for it to blend into one shape. So it might be a little bit misleading when you see this. It said edit top. So you might think that you're creating a profile for the top, but the opposite is true. At this point, we're creating the profile for the bottom. I'm going to use a rectangle to create the profile for the bottom. As always, I sketch and modify, so I'm making it bigger than I need. I'm going to use the align to align the left side of this line with the reference plane and lock it. Then we're going to place this line here at its correct location, which is 1 foot 1 1/4. One 1.25, same as the opposite side. 1.25. Enter. Now the thickness of this profile from the bottom. And let me remind you that whenever there's the reference plane and there is the profile line, always dimension to the reference plane first, whenever possible. So I'm placing this here, and the thickness of this is 1.5 inch. Enter. So now we're done with the bottom profile, but before we can get out of it, let's set the work plane for that bottom profile. Since this is the bottom, we want to set it to the base reference plane. So I'm setting this here, and the reference plane here would be the base, and we can OK out of it. Now that we're done, go ahead and edit the top profile. So same approach, I'm going to create a profile that's bigger than what I need, and AL align it. This side here, if you look back in the cut sheet, it goes straight up and down, okay? It doesn't have any taper to it. So I'm aligning it with the reference plane, and then I'm locking it. Now repeat the same process, okay? This thickness here is 3 inches. And these two lines in referencing to the center front back here, the distance is 3 1/4 inch on both sides. Oops, same as the opposite. 3.25 inch. Enter. All right. Same as the bottom. Before we can confirm it, we need to set the reference plane for it. So the reference plane here will be to the top of the table, however, 1.5 inches below. Okay, so I'm going to set the first end start at 0. That's the top of the table. And the second end, I'm going to set this to -1 inch. This time I'm making sure that there's a negative there. And then I can just hit the check mark. Save my work, of course. That's confirming that I am done with these blend. So let's take a look at it and see what it looks like in 3D view. It looks pretty good to me. I want to make sure that the top of the profile it's to the bottom of the table. So best place to do that is in front view. So I'm going there to double check. It looks like it does. Okay, so Compare this with the front elevation on the cut sheet. It looks exactly the same. However, in 3D view, we're not completely done with it yet. So let's continue by adding void geometry to subtract from this solid geometry to create the shape of the lake that we want. Best place for me to do this would be the left elevation. I'm on the left elevation. Create void geometry. This time I'm just going to use a simple void geometry. Looking at the solid geometry for the lakes from this view, I know that the maximum thickness is 3 inches. So the void geometry that we create will need to have at least the same thickness or thicker in order to cut through the entire solid geometry. I'm going to create the profile that I need, but this time I'm using pick line. I'm going to pick, again, right now I am selecting reference level, which I don't want. I'm going to tab until I get the base reference plane. I'm selecting that and I'm locking it to it. Okay, and the thickness of the lakes are 1.5 inches. So I'm going to use pick line again, and this time I'm going to apply the offset to 1.5 inch. Okay, then select the lake there again. And then I know that this horizontal line here is 4.5 inches. So pick line, offset to 4.5 from the bottom of the table. Then I will use the trim extend to clean up my profile. So I have the profile that I want, but I also want to make sure that the distance remain at 1.5 inches from the outside edge of the lake, and that doesn't change. So I'm going to place constraint to these two. Now you notice that there is no reference plane at all. So this time I'm dimensioning it from geometry to sketch line, geometry to sketch line. There's no other choice for me. So this is okay and acceptable. So I'm going to lock this dimension so it doesn't change. And before I can confirm, I need to double check to make sure that the reference plane is in the right place. In this case, I want my reference plane to be left of lakes or left of table. Set Workplane is center left right, so that's not what I want. I want it to be to the left of table, which I misspell. Okay, and I want the thickness of this to be 3 inches, and I get this wrong all the time, but sometimes it'll be placed toward the left of the plane, sometimes it'll be placed toward the right of the plane, but it's no big deal. If I get it wrong, I can always come back and add a negative value to it. So I'm going to confirm that I'm done with this geometry. It looks like it's create that cut for me, so the positive value works. So go to 3D view. That is the shape of the lakes as compared with the cut sheet. It looks pretty good. Before I forget, I want to go back and rename this. Okay, and I want to flex. So in 3D view, let's take a look at it in 3D view. Let's try to flex this. I'm going to move this to here. I'm going to flex between left and small and large. Small, apply. Large, apply. Looks like it is working. So let me double check again with front elevation. So let me okay out of it. Front elevation. And do the same for the top elevation, which is the reference level. Looks good. At this point, you may be tempted to just copy what you have done for the left to the right, or just mirror it from the left to the right. I want to strongly discourage you from doing that, because if you think of this as a standalone object, such as line that you drew on AutoCAD or a geometry you built in other 3D software, those objects are not referencing anything, but the object that we built in Revit is referencing a reference plane. So if you copy or mirror, it's going to throw that object out of whack, resulting this weird looking geometry. That is because this object here does not know what to reference to. So with that said, I want to strongly discourage you from mirroring or copying a previous object and start from scratch. So we're going to use blend just like what we did the last time, and we're going to create the geometry, the profile for the bottom. Aligning. And this dimension here is 1.25, enter. Same as the opposite, 1.25, enter. The thickness here, since I have the reference plane, I'm dimensioning it to the reference plane. 1.5 inch. All right, now that we're done with the bottom profile, I'm going to set and the work plane, I'm setting it to base. Okay out of it. Now I'm ready to create the top profile. Same approach, bigger than what I need. Align, lock, dimension. This is 3 1/4. Same. And lastly, 3 inches. Now that we are done with the top profile, we need to set the work plane for it. And for this, I want the work plane to be at the top of the table. Okay. And I want to make sure that it is -1 inch from the top of the table, which it is. That was the last value that was entered on for the top profile on the left hand side. So Revit remembers that. So I'm going to OK to get out of it. And let's take a look and see if we built correct geometry for the right legs. It looks good in this view. Looks like it is attaching to the bottom of the table. Let's verify that with front. Looks good. Now we're just going to have to do the void geometry again, and the best view for me is right elevation. So I'm double clicking on the right, and the reason why you can see through this geometry is because we're in wireframe. So I'm going to change that to hidden line. So you're going to see that solid geometry in front of the other legs. Repeat the same process again. So create void form, and I'm using void extrusion, just regular void extrusion. I'm going to set the work plane first this time. I'm setting it at right of table. And OK. And I want the extrusion to start from 0 and be 3 inches thick. Okay, now I feel like this time I need to have a negative value, but again, it doesn't really matter. Okay, I'm going to leave it at positive value for now and start placing geometry. I'm using pick line. Again, I want to make sure that I pick the base reference plane and not reference level. So I'm going to tap until I get base reference plane and lock to it. For the remaining, I'm going to have enter an offset value, 1.5 inch. Same as the opposite. And 4.5 inches from the bottom of the table. And then TR for trim extent to clean up the profile. Before I can get out of this, like we did the last time, so I'm going to place dimension and lock these two dimensions so that I can ensure that the relationship between these two lines will always stay at 1.5 inches. I think I'm now ready to confirm that I am done with the void extrusion. Go back to modify, create void extrusion, and then confirm. Now, it looks like my extrusion does not cut through the solid extrusion. So let's confirm that. So what I thought was right. My void extrusion projects toward me instead of toward the center. So I'm going to have to change this value. Again, while I have this geometry selected, I just need to add a negative value. Now it cut through that geometry. Last thing to do is to build the center support here. So here's what I'm going to do. With this, I have two choices. I can build and extrude the geometry from the top view, or I can build and extrude the geometry from the side view, the elevation view, left or right. This time I'm going to use the top view. So I'm going to be in reference view or reference level here. I'm going to use solid geometry from this view to create the center support. So create, extrude, and as always, sketch and modify. I use rectangular and create a bigger rectangular than I need. The thickness of this beam is 1.5 inch, which is 0.75 inches to the top and 0.75 inches to the bottom. So we get the total of 1.5 inches in thickness. For this line here, I'm going to attach to this reference plane here. Let's do that again. Lock. Do the same for the opposite. Lock. Okay. Now the extrusion also, this extrusion always need reference plane. So I want this reference plane to be top of the table. However, I want this beam to attach to the bottom of the table, which is -1 inch. So I'm going to OK out of it. Here we will select top of table as a reference plane. Setting the extrusion start to -1 inch, and since the thickness of this beam is 3 inches, the extrusion end will be -4 inches. And then apply. I think I'm ready to confirm that I'm done with this extrusion, so I'm going to confirm it. Let's take a look and see what it looks like in 3D view. It looks good. Let's confirm it with the front elevation. It looks good. Now, back to 3D view. Last thing that we want to do is we want to join these three geometry together to get rid of that weird connection line. Okay. I don't know why we still have this. There we go. We're done with this family. Last thing to do is to flex it one more time. Looks good. Let's confirm it with the front elevation. Okay, looks good. Lastly, with the top elevation. Looks good. We can OK out of it and save your work. And don't forget the last step. Load your finished family into a project file and test to see if it's working correctly there as well.